So, I was scrolling through my wallet last week, and I stumbled across an NFT I bought back in 2021. It was supposed to be this cool generative art piece, but when I tried to view it, nothing loaded, just a broken image icon.
Welcome to one of crypto's dirty little secrets. A huge percentage of NFTs from the last bull run are either broken or on life support.
That's the thing that gets me. I thought blockchain was supposed to be permanent, immutable. Yet here we are with thousands of dead JPEGs that only exist as worthless tokens pointing to nothing.
Right, and that's because most people fundamentally misunderstand what lives on chain versus what doesn't. When you buy an NFT on Ethereum or most other chains, you're not actually storing the image or metadata on the blockchain itself.
You're just storing a pointer.
Exactly. The token exists on chain, but it's pointing to off-chain storage, usually IPFS, or sometimes just a regular web server. And here's the problem. IPFS requires active pinning. Someone has to pay to keep that data available. When projects fail or funding dries up, the pinning stops, and suddenly, your NFT metadata disappears into the digital void.
There's actually a new tool called NFT Timeless that lets you run a health check on your NFT collection. I tried it, and let's just say the results were sobering. About 15% of my collection is either broken or at risk.
That tracks with what we're seeing industry-wide. And for NFTs stored on centralized servers, even worse. When the company goes under, those servers go offline, and everything is just gone. No recovery possible.
So we have this massive problem, but there's been a new development recently that's supposed to help, right? I saw OpenSea announced support for something called ERC 4804. What is that exactly?
ERC 4804 is a really clever standard that introduces a new type of URI. Instead of IPFS or HTTPS, it uses Web3://. Think of it as HTTP for Ethereum. When a marketplace sees a Web3:// URI, it knows to fetch the metadata directly from a smart contract instead of going off-chain.
So the metadata actually lives in the contract.
Either in the same contract or in a separate metadata resolver contract. The key is that the marketplace translates that Web3:// link into an ETH_call, executes it against the contract, and gets back the metadata as a response. No external dependencies.
That sounds promising, but I'm guessing there's still a catch.
Well, it's definitely better than relying on IPFS or centralized servers, but you're still working within Ethereum's constraints. Storing large amounts of data on-chain is expensive, really expensive. So while ERC 4804 solves the accessibility problem, it doesn't fundamentally change the economics.
Which means most projects still won't put their actual art on chain?
Not unless they're willing to pay a premium. You might see it for high-value collections or projects that are deliberately keeping things simple, like text-based NFTs or minimal generative art. But for anything with significant file sizes, the cost is prohibitive.
Here's what interests me about this, though. The standard also lets old NFT projects retroactively fix their metadata without migrating to a new contract. That seems huge.
It is. You can deploy a new metadata contract, store your data there, and then update your original NFT contract's base URI to point to the web3.eth address. The tokens themselves never move. From the user's perspective, nothing changes, except now their NFTs actually load again.
So it's like a repair mechanism for already launched projects.
Exactly. And that's why OpenSea adding support matters so much. If marketplaces don't recognize web3.uris, the standard is useless. But now that OpenSea is on board, we'll probably see wider adoption across the ecosystem.
Okay, so this is a step forward for Ethereum. But earlier you mentioned that storing data on chain is expensive. Is there a blockchain that's actually designed to handle this kind of workload without the cost barrier?
That's where the Internet Computer Protocol becomes really interesting.
I've heard the name, but I'll be honest, I don't fully understand what makes it different.
So most blockchains, including Ethereum, were designed as decentralized ledgers. They're great for recording transactions and executing smart contracts, but they were never built to host full applications or store large amounts of data efficiently.
Because every node has to store everything?
Right, and computation is expensive because you're paying for global consensus on every operation. But Internet Computer was designed from the ground up to be a decentralized cloud. Instead of just hosting smart contracts, it can host entire applications, front-end, back-end, databases, everything.
So, how does that actually work? ICP uses what they call canisters, which are like supercharged smart contracts.
A canister can store code, data, and state, and it can serve web content directly. You don't need a separate server or IPFS gateway. The entire application, including all its assets, lives inside the canister and is served directly from the blockchain.
So, if you minted an NFT on Internet Computer, the actual image file would be stored on-chain?
Exactly. Not a pointer to the file itself. And because of ICP's architecture, the cost to store that data is orders of magnitude cheaper than Ethereum. We're talking a few dollars to store gigabytes versus thousands on Ethereum for far less.
Wait, how is that possible? What's the trade-off?
The main trade-off is a different security model. Ethereum achieves security through massive redundancy. Every node stores every byte. Internet Computer uses what's called chain key cryptography, which allows much lighter verification without needing to store everything locally.
Is that less secure?
It's not less secure, it's differently secure. Chain key cryptography is actually quite robust. It allows nodes to verify state without needing to store everything locally. The real question is whether you trust the cryptographic assumptions underlying it.
Which is a legitimate question for any new protocol.
Absolutely. And ICP is still relatively young compared to Ethereum, but from a pure technical standpoint, the architecture is compelling. You can host a fully functional social media platform, complete with user-uploaded images and videos, all on-chain. That's not theoretical. Projects are doing it right now.
So for NFTs specifically, this means you could mint a collection where every piece of metadata, every image, every attribute lives permanently on-chain with no external dependencies.
Correct. And because the cost is manageable, it's actually viable for projects to do this at scale. You're not limited to low-res images or text-only metadata.
That changes the equation pretty dramatically.
It does. But here's the thing. ICP isn't trying to replace Ethereum. It's solving a different class of problems. Ethereum is optimized for financial applications, security, and composability within DeFi. ICP is optimized for hosting decentralized applications that would traditionally require cloud infrastructure.
So it's less about competition and more about different tools for different jobs.
Exactly. And if you're building a DeFi protocol, you probably want Ethereum because of the liquidity, the security guarantees, and the established ecosystem. But if you're building a social platform or a game or an NFT project where you need to store a lot of data and serve it directly to users, ICP's model makes way more sense.
So what about interoperability? If I have an Ethereum NFT, can I somehow move it to ICP?
Not directly, but there are bridging solutions in development. The bigger question is whether projects will choose to launch new collections on ICP specifically to take advantage of the on-chain storage.
Have we seen that happening yet?
There's definitely growing interest. A few projects have launched fully on-chain NFTs on ICP, and they're marketing that durability as a key differentiator. No IPFS pinning required, no server maintenance, no ongoing costs to keep your NFTs alive.
That's actually a strong selling point, especially after people have watched so many projects from previous cycles completely disappear.
Yeah, and I think this is where the broader conversation about NFTs needs to evolve. We spent years talking about art and profile pictures and speculation, but we never really addressed the fundamental infrastructure problem.
Which is that most NFTs aren't actually stored in a durable way.
Right, and standards like ERC 4804 are a meaningful step forward for Ethereum, but they're working within constraints that were never designed for this use case.
ICP's approach is purpose-built for it. Do you think we'll see more chains trying to solve this problem?
I think so. Arweave is another example. They offer permanent storage through a one-time fee model. Filecoin is trying to create a decentralized storage market. Each approach has different trade-offs, but they're all acknowledging the same underlying issue.
Which is that if we want NFTs to be truly permanent, we need infrastructure that supports that.
Exactly. And what's interesting is this isn't just an NFT problem. It applies to any decentralized application that needs to store and serve data. If you're building a decentralized social network, you need somewhere to store posts, images, videos. If you're building a decentralized gaming platform, you need to store game states, assets, metadata.
So the NFT issue is really just exposing a much larger infrastructure gap in the ecosystem.
Completely. And I think over the next few years, we're going to see a lot more experimentation with different storage models and hosting solutions. ERC 4804 is one approach, ICP is another, Arweave is another. They're all trying to answer the same question. How do we build applications that are genuinely decentralized and don't rely on centralized services staying online?
Let me play devil's advocate for a second. Does this even matter for most NFT projects? Like, if I'm buying a Bored Ape, do I really care whether the metadata is on-chain or stored on IPFS?
That's a fair question. For established high-value collections backed by well-funded teams, you're probably fine in the short to medium term. Yuga Labs isn't going anywhere, and they'll keep paying for IPFS pinning or migrate to better infrastructure if needed.
But for smaller projects, newer artists, experimental collections?
Those are the ones at risk. And honestly, those are often the most interesting projects. We've already lost a ton of creative work from 2021 and 2022 because projects ran out of funding or shut down.
So, if you're a creator launching a new collection today, what should you be thinking about?
I'd say prioritize durability from the start. Either go fully on-chain
Using a platform like ICP, or at minimum, use ERC 4804 on Ethereum to ensure your metadata is contract-based and verifiable. If you're using IPFS, make absolutely sure you have a long-term pinning strategy and ideally multiple redundant pins.
And if you're a collector?
Ask questions. Where is the metadata stored? Is it on-chain or off-chain? If it's off-chain, what's the backup plan? A lot of collectors don't think about this until it's too late.
It's like buying physical art without checking if it's archival quality.
Great analogy. You might not care at first, but 10 years from now, you'll wish you'd asked.
All right, let's zoom out a bit. Where do you think this all goes? Do you see a future where most NFTs are fully on-chain, or will we always have this hybrid model?
I think we'll see segmentation. High-value art, historical collections, culturally significant pieces, those will likely migrate toward fully on-chain storage as the technology matures and awareness grows. It becomes part of the provenance and value proposition.
And everything else?
Probably stays hybrid for a while. IPFS with better tooling, maybe more adoption of ERC 4804 for Ethereum projects, and gradual migration to purpose-built platforms like ICP for new launches where on-chain storage is a core feature.
So it's not winner take all, different solutions for different needs.
Exactly. And I think that's healthy. The key is making sure creators and collectors understand the trade-offs and make informed decisions.
One last thing I want to touch on. You mentioned earlier that ICP can host full applications, not just NFTs. What does that enable that we're not seeing elsewhere?
The big one is on-chain AI, because ICP can run computationally intensive workloads directly on the blockchain. You can actually host AI models as canisters. The model, the training data, the inference, all verifiable and auditable on-chain.
Why would you want that?
Transparency and trust. If an AI model is making decisions that affect users, like content moderation or credit scoring or automated trading, being able to verify exactly how it works and what data it's using is huge.
That's a whole other conversation.
It is, but it's all connected. The same infrastructure that makes fully on-chain NFTs practical also makes on-chain AI practical. It's about building genuine alternatives to centralized cloud services.
Which brings us back to the original vision of Web3.
Exactly. Not just decentralized finance, but decentralized infrastructure. And that's what makes this moment interesting. We're starting to see the tooling catch up to the ambition.
So if someone listening to this has NFTs that are at risk or broken, what should they do?
First, run a health check using something like NFT Timeless to see what's actually broken. If you're a creator with a collection that's at risk, explore migrating to on-chain metadata using ERC 4804, or consider redeploying on a chain like ICP for future projects. And if you're a collector, start asking tougher questions about durability before you buy.
Good practical advice.
And honestly, this is one of those areas where the industry needs to mature. We can't keep losing digital art and culture because we didn't think through the infrastructure.
Agreed. All right, let's wrap this up. The big takeaway here is that the NFT durability problem is real. It's affecting thousands of collections right now, and there are solutions emerging, both retroactive fixes like ERC 4804 and forward-looking infrastructure like Internet Computer. The key is awareness and making informed choices.
Well said. And I'd add that this isn't just about preserving JPEGs. It's about building an internet where data and applications can exist independently of corporate infrastructure. That's the promise, and we're finally seeing the technology to deliver on it.
It's been a great conversation. Thanks for walking through all of this.
Always a pleasure.